Hello and welcome to episode 16 of the Artisan Workshop modding series. We are almost done with our mod, so if you have following from the beginning, good job, just a bit more. But we still need to talk about harmony, which is probably the most controversial topic amongst modders, although I don't think there's any good reason for why some people hate harmony so much. It's just a tool, and it is often the best tool for the job, so people keep using it. But let's see where we are with our mod. So let me launch this and show what we did last time and what we need to fix. So we were doing our brewery management UI, and over here we have now the ability to set the production efficiency for the workshops. So we could, for example, set the workshop efficiency to 40%, in which case the workshop should be working much slower than usual. But we did not actually hook this up to anything, so we still need to modify the existing workshops in the game to work at the rate of efficiency that we set over here. And to do this, we are going to use Harmony. So Harmony is a library that allows you to alter functionality of existing programs during the runtime by changing methods. So in this case, we are going to use Harmony to change the existing game code. And Harmony works by runtime monkey patching. So when you start your game, Harmony will do the changes that you specify, but it will not permanently change anything about the game. And Harmony also has nice support for multiple people doing changes at the same time, even to the same methods, although there can be problems with the changes clashing with each other. Pretty much it is the best possible tool that modders could wish to have. There are some limitations though. You cannot change the existing data structures, just the methods. So if you wanted to add data to the existing objects, you would have to do something creative to get around that limitation. But let's go into the Harmony documentation and look at the actual capabilities of this library. So the three basic operations of Harmony. So the three basic functionalities of Harmony are Prefix patches, Postfix patches, and Transpiler patches. And we will look at these starting from the simplest one, which is Postfix. So using a Postfix patch, you can append your own code to an existing method in the game. In a Postfix patch, you will get the result of the original method. You could change the result, you could do some branching based on the result, or do whatever else you want to do. So here's an example of a very simple Postfix patch. They get the result of the original method, and based on the result, they might replace it with something else. So next up, let's look at Prefix. And Prefix lets you run your own code before some existing method. So anytime some method in the game is called, before that code actually gets to execute, your code will run first. And this will be a bit more powerful than a Postfix, because in a Prefix, we can also decide that we don't want to run the original at all. So a Prefix can be used to completely replace some method if you just write your code in the Prefix and then don't let the original run at all. And the third way to do a patch is with transpilers, but let's look at those a bit later. First, let's try to implement our change using a Prefix. Let's try to find where in the game workshop production is handled. So let's search for classes named workshop, and I think it will be in workshops campaign behavior. Over here, you have daily tick, where they run every workshop. So every day for every workshop, they will call this run town workshop. And it seems pretty reasonable to assume that this code will do the production for the workshops. And if we try to quickly look at what this is doing, they take the current production progress into a number here. Then they do some magic to try to determine the speed of the production, depending on some perks, governors, policies, things like that. In the end, they get this explained number based on the perks and stuff. And then they add that to the number that was the previous production progress. And if this number is larger than 1, or while this number is larger than 1, they will do production and then decrement the progress by 1. So whenever this num reaches 1, that means that the workshop will do one round of output. And at the end, whatever is left after the whole numbers have been removed will be stored as the progress for the next day. So if we wanted to add our own production efficiency multiplier somewhere in here, I think the reasonable place would be to add it over here. We could multiply this result after all the perk calculations with our own production efficiency multiplier. But since this operation is done in the middle here, I don't think we have a good way of using a postfix to do our change. I don't see which method we could postfix patch to add our change here. Like if over here they called something like get the daily production or something, get the daily workshop production, then we could postfix patch that method and multiply the result with our efficiency. But over here, I think to modify this, we will have to replace the whole thing. So let's try to do just that. Let's write a prefix patch that will replace the whole thing with our own implementation of the workshop production. So let's start by doing some mandatory setup for Harmony. So in your submodule, you will have this on submodule load, and this is the very first thing that will be run when the game starts and loads your mod. So it is customary to set up Harmony over here. So we can do just that. And in the mod template that we used, you remember that the mod template created this submodule.xml for us. And the mod template always already depends on Harmony from the very start. So so all this time we have had this Harmony dependency over here, but we have not used it until now. But everything should be ready that you can just start using Harmony without any additional changes to your project. So to initialize Harmony, let's just get a Harmony instance. So you need to add a using statement for HarmonyLib, and then we can do new Harmony with a unique ID for your mod. And then the only thing you need to do is Harmony patch all. And this will apply all the patches you write using the attribute system, which is exactly how we are going to write our patches. So the attributes are these things. So the patch all will search for all of these classes marked with a Harmony patch, and then just applies all of those. So this is all the setup that we need. And let's make a new file for our patch. So let me go add class, and let's call this workshop patch, and augment it with a Harmony patch attribute. So let's write the attribute that will mark this class as a Harmony patch. So let's do Harmony patch and add the using statement. Then we need the type of this class that we want to modify. So workshop campaign behavior. And then we need the name of the method that we want to change. So run town workshop. And that is everything we need to do to mark this as a patch. And at this point, we can just write our prefix. So let's do static bool, and this needs to return a boolean because the return value will determine if the original method should be run or not. So to let the original run, you return true, and to not allow the original to run, you return false. So we don't want the original to run, so we should always return false here. And now we need the original code. We will need the original arguments, so we can just copy these like so. We need to add using statements for this. And then we can copy the original code. But here we need to do some changes to make this work. Well, first we need to add some more using statements. So first of all, here they have return statement. Well, we can just replace this with return false, and that will work for us. But then more tricky will be, for example, this place where they use local field. private field, because we will not have direct access to any of these private fields. But luckily for us, there is a way in Harmony to access private fields from a patch. So if we go into the injections, they have these fields, which is intended just for this purpose, to get a field from the original instance. So by prefixing the name with 3 underscores, we can get any field, even private field, from the original instance. So let's try this out. So we need 3 underscores here. Then we need to figure out the type for the player-owned workshop. Player-owned workshop is in bankruptcy. So this will be the type. And over here in the arguments for our prefix, we can just write that we would like to have an argument with this name and this type. And Harmony behind the scenes will do all the magic to get this private field from the instance for us here. But we still need to call do production. And is do production private or public? It is also private. So first of all, we need the instance that used to be called this. And in Harmony, you can get that by adding another argument, this time called underscore underscore instance. And this will let us get the original workshop campaign behavior, and we can use that. And then we can call the do production method on that original instance. So let's do just that. Let's get workshop campaign behavior underscore underscore instance. And over here, where it used to say this, we can replace this with underscore underscore instance, but we still have the issue that do production is private. So since it is private, we cannot just call it like this, but instead we have to go through some hoops to call a private method. But luckily in C#, calling private methods is not that difficult if you are willing to use a reflection. So in Harmony, they also have these access tools, which has all sorts of convenient functions you can use to get private fields or private properties or private methods for calling purposes. So let's write over here, do production, and let's get the original method using access tools. So let's write access tools method. Then we need the type of workshop campaign behavior and the name of the method as do production. And just like this, we can get runtime method info of this method called do production that we can use to simulate a call of this method. So we will need these arguments, the original arguments, but the calling syntax will be a bit different. So we need to do production. We need to do production invoke. And here the first argument will be the instance, and the second argument will be list of the parameters. But we need to wrap our arguments in this object array. So let's write new object and wrap the arguments in brackets. And in the end, we also need to cast this into Boolean, because the invoke just returns an object and the do production method returns a Boolean, and we sort of lose the type information by doing this trick. So we have to do explicit cast here. Just like over here, we explicitly casted all the arguments into objects. So this will basically lose all the type information from the arguments and also from the return value, so that this method invocation can happen completely typeless. So now, as long as this compiles, we should have a perfect copy of the original run town workshop method. So now, to change the speed at which the workshops operate, we could just do our calculations right here. So let's see how we could figure out if we actually manage to change how the workshops work. So over here, when the workshops produce their outputs, they dispatch an event here, campaign event, called onItemProduced. So let's go ahead and add a listener for this event in our behavior onItemProduced, and then maybe we can see if we can notice changes in the workshop output. So let's go into our Artisan beer behavior and add a listener for, let's add a listener for onItemProduced. And the arguments are item, settlement, and the amount. So over here, let's just do information manager, display message, and this will write as a line of log every time some workshop manages to do its job. Let's do string format was produced in, and the city name. So this will be item name and settlement name. And let's add a condition here that checks that the item produced was beer, so that we get less messages, because otherwise it might be a bit difficult to read. And you can see that there is fairly constant stream of beer being produced in various cities. So now let's add a production multiplier of, like, for example, 0.01, so 1% of the original output. Let's see if we can notice there being less beer produced over the world. And now we get no messages at all. So let's try multiplying the campaign speed. So let's go with speed of, say, 50. And with this improved speed, we will eventually get some lines of beer production. So it would seem that our patch is working. And just to double check, let's go and multiply the production by 10. So let's wait. And then you get a lot of stuff being produced everywhere. So now we need some sort of way to get the desired production efficiency for a given workshop. Let's go into our Artisan beer behavior. And in our behavior, let's add a static public method that will give us our production efficiency. And this should be static so that it will be convenient to call from our patch. So let's call this workshop production efficiency. And the argument will be a workshop. Okay. So now we would like to get the Artisan workshop related to this workshop. But since this is a static method, we cannot directly access the Artisan workshops, which is not static. So let's add here a static public Artisan beer instance, or Artisan beer behavior instance. And on session launched, let's set the instance to this. And over here in our production efficiency, when we need to get the Artisan workshop, we can call instance Artisan workshops with the given workshop. And this will be our Artisan workshop. And our return value will be a multiplier between 120% and 0, depending on the Artisan workshop daily production amount. So every unit of daily production will reduce the production by 20%. And now we can just go ahead and in our patch, we can do Artisan beer behavior, workshop production efficiency, given this workshop. And over here in our production efficiency, I want to limit this to just breweries. So if we are not looking at a brewery, we should just return multiplier of 1, so no change. So this is the code that I actually want to write, but I think for testing purposes, I will change this a bit so that it will be easier to see our patch is actually working. So let me do something completely different for now. Let's say that if the daily production amount is 0, then we produce 100, then we produce like 20x, and otherwise we produce nothing. So now you only produce if you set the artisan beer production amount to 0. So while we are testing, let's set the artisan's production to 0 so that we can easier see the output just from our breweries. So now there should be no beer production unless I set manually one of my own workshops to producing 0 artisan beer per day. So now you see there is no beer being produced anywhere. If I go into my brewery and manage workshop, set this to 0, then you can see, well, sometimes you can see that there is now beer being produced in Danglanus and in high quantities, very high quantities. So our patch is working and it is connected to our management screen. So now we are basically done. Our patch successfully controls the amount of production from the regular workshops. But one downside of this approach is that we had to replace whole runtown workshop method to do our change, which is not ideal, especially if this was code that Tailworlds is patching with every update or something. We would have to come back and copy all this code again. Also, if other people have added postfix patches to this method, runtown workshops, our prefix patch here would not allow those potential postfix patches written by other people to run at all. So this is kind of selfish in that way. So arguably a better approach than just replacing the whole original method would be to write transpiler that can just slightly modify the original code. So let's look at how you write transpilers next. So transpilers are the third type of patching method in Harmony. So transpiler is a way to alter the source code of the original method. So when you write a transpiler, you will get a list of code instructions and you will output another list of code instructions. And this code that you get to modify is not C#, but it is the net runtime intermediate language code. So to see what that looks like, we can use dnspy. And if you right click somewhere, you can see edit intermediate language instructions. And that will give you a view like this, where you can see the individual intermediate language instructions. So for example, here is their call to get result number, which is this part dot result number. And other things you can see here they have the call to add bonus for character, for example, over here. And after they get the result number, they have add here. And that add is this plus sign here, and so on and so forth. And here is an example of what transpilers typically look like. You get the list of instructions, you iterate over them, you look for something specific in the original code, and when you find it, you insert your own stuff in between, and then you keep returning all the original stuff as well. And this will be the pattern that our patch should follow as well. So in here, where they do the add, we want to do our own multiplication. So if we look at the patch we wrote in C#, over here in this add line, we added this multiplication with the number we got from a static call. So presumably we will have to do static method call and then a multiplication. So first, let's write our transpiler up to the point where we can find the correct place where we want to add our own code. So I think we can copy this example over here. And soon, I don't think we will need this prefix anymore. So let's comment this for now so that we can compare later between the two approaches. And then here we can copy this transpiler from the documentation. I think here where they had a report error, we can throw argument exception, new argument exception. And let's replace this. We are looking for, if we look at the original code, we are looking for explain. I want to put our code here before the add. So let's look for explained number get underscore result number. So to do the comparison, we will need the method info of this thing that we are looking for. So let's try to find that. Get result number, and we can use the access tools again to get this method. So type of, so we are looking for this method in the type of explained number. And what we are looking for is get underscore result number. So method with this name. And we are looking for instruction where the opcode is call. So let's see opcodes. Wait, where are the oh, here you have opcode call. So like this, opcodes call. And where the instruction operand is the method that we found, hopefully. Oh, opcodes is not in the scope though. And this is complaining about mismatch of types. So let's cast this to method what? Method info. So let's run and see if this works. And this will be executed at the very beginning of the startup. So immediately we hit this thing. And here you can see the list of instructions that we got from Harmony for this method. So we can compare this with the list we have in dnspy. So if I scroll all the way to the top, you can see that the first one should be a load argument 2, which you see right here in slot 0. The next one should be call virtual workshop get is running. Call virtual workshop get is running. So you see that these two match, which is very good. And then we can put another breakpoint here inside this loop where we have found our target. Oh, we got an error from the cast. So this was not a good idea. Oh, well, we can just cast this into an object. Okay, let's try again. Let's see if we hit the breakpoint this time. We do. So you see, so the current instruction is call to explained number, get result number. So you see that our if statement here is working, and we can find the place where this line is. And this should be hit only once. So if I now continue again, we go back into, we continue the normal loading sequence. So over here, we need to figure out the code that we want. So just like they do here, we should yield our own instructions that we want to insert around this point. And actually, we want our stuff to be after the call. So I should put this yield the original instruction on the top. So there are many ways to figure out what you need. You could, for example, code the thing you want in C#, and then go in dnspy and look at the instructions created for your code. But I think the simplest way is to just know what you're doing, learn a bit about the intermediate language. So if we search for common intermediate language instructions, we get Wikipedia article with list of instructions. So here, if you know a bit about stack languages, they should be fairly straightforward. This is, so for example, if we want the multiplication, we just add mul, and this will get the first two values from the stack and multiplies them together. So if I write a mock here of what we want the call to result number. This will put one value on the stack, which is the number that we want to multiply. Then we should put our own value on the stack and then multiply and then add. And the add will be this next line over here, 72. So these two parts are what we need to add. The part where we get our own multiplier and then the actual multiplication itself. So to get our own multiplier, we should call our static method, which was called Artisan beer behavior workshop production efficiency. But we also need this argument. So after call to result number, we call our workshop production efficiency, then we multiply these together, and then we let the original add. And to give arguments for a call, you need to push those arguments onto the stack beforehand. So here, for example, you see that when you call get result number, you don't give any arguments on this call line, but instead these lines beforehand, or I guess only this one line, is the argument for this method. So before we call our method, which is workshop production efficiency, we should load the argument, in this case the workshop, onto the stack. And the workshop is given as an argument over here to the method that we are patching. So that will be, so over here you will have 0th argument, which is this, so the instance of workshop campaign behavior. Then you have first argument town component, and then the second argument workshop. So this should be load second argument. So to get this workshop onto the stack, we should do load argument 2, which you see, for example, here. So here, for example, after load argument 2, they call workshop get production. So this is how you call this method get production on this argument that you are given. So in our code that we need to add, this workshop line will be load arg 2. And then we can just call this method and everything should work just fine. So let's go ahead and write these 3 lines over here. So the first one will be our load argument 2. So load argument 2, and this will not have an operand, since load argument does not accept an operand. Second line will be our call, and we want to get our method. So to do that, we need to do access tools method type of artisan beer behavior, and then we can use name of to get the name of the method without any fear of typos. So this will be workshop production efficiency. So that is our call to this method. And then finally we need to do the multiplication. So opcodes mul and give that null as well. And over here I want to add another sanity check, which checks that we only find this thing once. It would be bad if this get result number was used multiple times. So found multiple. Yes, so this is another sanity check that our patch is working as intended. So that should be the equivalent of doing this thing, but using Transpiler instead. So now it is the moment of truth, and we can try and see if this actually works. So let's wait, and right now none of the workshops should be producing anything. So let's go campaign speed 30. And let me go into my brewery and set the artisan beer production to 0. And now the Danglanus brewery should start producing again. And we get production here. So that's great. It seems like the Transpiler patch is working as well. And one more thing we can do to convince ourselves that it is working is to add a breakpoint here in the workshop production efficiency and see that it is hit. And the call stack will show that this method is called from some weird place inside workshop's campaign behavior. So exactly what we want. And this lightweight function is whatever Harmony created for the new version of the method after our patch has been applied. So that looks great. And the workshop argument we get here looks just fine. So we have successfully passed a valid workshop onto our workshop production efficiency from our patch. So we can be reasonably sure that the load argument 2 was the correct choice here, and our method call is working. So now, personally, I prefer this version. So let's just go ahead and remove this prefix thing completely. We don't need it anymore. And I will remove the debugging stuff I added here. So this line is only for debugging, and the line that disables artisans is also only for debugging, and everything else can stay. And with that, we have completed the Harmony part of our mod. And in case the Transpiler stuff looks scary to you, I recommend that you play around a bit with some other stack-based languages first, and then just try writing different patches with transpilers, and over time it should get a lot easier for you. But if you just want to write prefix and postfix patches, that is of course totally fine. And in that case, you can write your code as normal C# code. So to recap, Harmony is a runtime reflection library that can be used to patch existing methods with either prefix patches that run before the original method, or postfix patches that run after the original method, or with transpilers that allow you to modify the original method's code in arbitrary ways. So for example, in our case, we added our 3 instructions in the middle of the original method, but since you get a raw list of instructions, you can do any arbitrary edits to the original that you desire. Also, Harmony has some utilities that let you access private fields, private methods, and all that good stuff. And now everything related to gameplay in our mod is complete. And in the next episode, I will be adding localization so that our mod will support translations. And after that, we are basically done with everything except small polishes and maybe some bug fixes. But for now, thank you so much for watching, and I hope to see you in the future videos.